Okay, so this last topic is called nonlinear systems. And some of these slides are going to be the same slides we saw at the beginning last time. So you don't need to copy down every word. But we know what we mean by a system. A system means more than one equation. A nonlinear system means one of the equations is not a straight line. Right? It could be that both of them are not straight lines, but at least one is not a straight line. That's why it's called a nonlinear system. Okay, we know what it means to be the solution to a system. It means the places where the graphs cross, the intersection point, the point that satisfies both equations. The thing is, when it's a straight line, there could only be one solution. There could be one, or there could be none. I mean, there could be infinite, but in any case, that's not a unique solution. When it comes to a linear quadratic system, these are all the possibilities for the shapes of quadratics. The only one that we've studied so far is a parabola. But even if you're just looking at a parabola and a straight line, you're definitely looking at the possibility of having more than one solution, right? But still, where are the solutions? It's wherever they cross. I mean, there will be questions on our test, on the SOL, whatever it says. What are the solutions? And you're looking at a graph. So you want to be able to say, these 2 points, don't look for the x-intercepts. That's what we used to say when we were just solving a quadratic equation or a polynomial. Now, this is what we're looking for, those 2 points. So, and I'm not going to go through all that. So we've already talked about what we mean by substitution and elimination. Okay, we will do that with nonlinear systems this time. We didn't talk about the graphing, and we need to do that. We'll do that with the linear systems first. And then I'll give you the 2 problems to work on in class that we did that were supposed to be on our homework. And then we'll go on and do the rest of this. All right, so solving by graphing, and you need to try to play along with this. The first step in solving by graphing is, if you look at your calculator here, you put equations at y equals, so you need to solve them for y. Right? So that can be like the hardest step, especially with the nonlinear systems. You need to solve the equations for y before you start. So in this one, right, this would be 4y equals negative 3x plus 12. So y equals negative 3/4 x plus 3. This one, subtract the 2x. Y equals negative 2x plus 10. Done. So the first step, solve the equations for y. Okay. And those are the 2 equations.
So what would you have to solve for x? Or?
No, you solve for y, right? Look on your do you have an x equals button? It's y equals, right? Solve for y. Okay, now put those equations in the calculator, like I've got already shown here. That you don't have to use the fraction notation like that. I mean, you could just say 3 divided by 4. That's fine. But if you want to use the 3/4, you remember how you can get the fraction bar to come out? Yeah, remember you go alpha, y equals 1. So, but you don't have to. You could just say negative 3x divided by 4. Either one is fine. But in any case, you want to have 2 equations on the calculator. Step 2. Got them in there? Got it. Okay, now if you look at the graph, and if your graph doesn't come up to the middle of the graph, you can always do a zoom 6 so that it does. But it should look like that right there. Does your graph look like that? How many solutions do you see? One, right? Remember, it's the intersection of the line. So the intersection is about right here, which you could estimate off the graph. 1, 2, 3, 4, 5. It looks like it's x is between 5 and 6, and y is between -1 and -2. I mean, it could be in a multiple choice question. I mean, that's enough to identify the answer right there. Okay. But now we're going to learn how we use the calculator to actually find that exact point. Okay. So this is what you want to do. This is step 3. Step 3 is second trace. So second trace, and you should see that menu come up right in front of you. And you're going to hit intersect, 5 for intersect. Right? It should look like this. Right? It's going to tell you, it's going to be asking you a question. First curve, and you can see in the upper left corner that it's got one of those equations written there. And you're always going to say, yeah. I mean, you should see the cursor, it's probably blinking about right there. Yeah, x equals 0, y equals 3. It's right there at this point. And are you okay with that being your first equation? Sure. So you just hit enter. Hit enter. Step 4, hit enter. And when you do, it should look like this. Now it says second curve, and you see the other equation is up there. It's got to grab both equations, or else you're not going to see the intersection. So are you seeing that? And you can see the cursor now has jumped to 0, 10. It's up there. But that's definitely the other graph. Right? The first time it was here, now it's up there. Okay, hit enter. And when you do that, it's going to ask you guess, and you always say yes. Just hit enter. And when you hit enter again, it looks like that intersection. And it looks like the point is 5.6 for x, -1.2 for y. The cursor is blinking now right there on the intersection point. Okay, we get that? Did anybody try it and not get it? If you don't try, there's nothing I can do to straighten you out, okay? So these were the steps that I said. First, we solved both equations for y. Then we entered them in the calculator. Then we did second trace 5, enter, enter, enter. As long as the intersection is on the screen, it'll find that point. It can be sometimes that the intersection point is not on the screen, and then you need to zoom out so that it is. Okay. So try to do the same thing with those two. And they're already solved for y. So all you need to do is put them in the calculator. Who's got an answer? You get it? 2 negative 3. Looks right. Looks right. Looks the same. You got it. Got it. Got it. And Hunter sleeps away. That's a good way to succeed here. There you go. Pretty easy, right? Did you do it? What are you waiting on? See, most people, if people tried it, if they're following along, it comes very easy, doesn't it? It's up there. So you have, like I say, because the way you've got a graph there, you don't actually see the intersection point. It can't find it. If you go zoom 6, now you're like, it brings it back to the middle of the screen, and now you see it. So now do the same thing. Second, trace, 5, enter, enter, enter. Done. That's it. The intersection point is not on the screen. No, that's not what we said. We said second, trace, 5. Okay, then you didn't put them in right. Negative 3x plus 3, 2x minus 7. Let's put it back to the middle of the graph. So we go second, trace, 5. Enter, enter, enter. 2, negative 3. Okay. So the answer was 2, negative 3. So in your book, go to the page. These were the two we should have done on the last homework, but we didn't because we didn't have time to go over it. So go ahead and do these two, 139, 30, and 31. 5 minutes. So the first one looks like 4, 2.5. If you put it in a fraction, what you got 5 halves, right? But it's same thing. So 4, 2.5. Okay, how about the second one? What do you have to do before you can put it in the calculator? You gotta solve for y. So this is 6y equals negative 3x plus 12. Y equals negative 1/2 x plus 2. So the first equation, negative 1 half x plus 2. The second, 2y equals negative x plus 8. Y equals negative 1 half x plus 4. Drop it away. What'd you get when you put that in? No solution, right? I mean, look at these lines. What's the slope of each line? It's negative 1 half. It's got the same slope, which means they're either parallel or they're the same line. In this case, because the y-intercepts are different, they're parallel lines. So when you try to do the second trace 5, you're going to get an error. There is no solution. And if you looked at the graph, you would see, yeah, they don't cross. I mean, the nice thing about this thing is it helps you solve any kind of equation. I mean, anything that we've done from the beginning of the year till now, and this was a question actually on our last test, you can use this method to solve. And you do it like this. If this equals this, then in your calculator, you would write it like on the first line, put 1 over x minus 6. On the second line, you put x over x squared minus 36. And then you look for where they cross using the exact same steps. So it really becomes a way to solve the more complicated kind of equations you can use like that. Now, this one might be a little different because it's got some vertical asymptotes on it, but this method is going to come in very handy when we're getting ready for the SOL. Okay. So then we go back. These are the same steps we used for substitution, so you don't need to write these again. The difference now is, now we have nonlinear systems. And if you look at this nonlinear system, I mean, if I follow the steps would say solve one equation for one variable and then substitute into the other equation. The thing about some of these nonlinear systems, let's say that I decided to solve the first one for x. When I plug into the other equation, I really don't need x. I need x squared. So there's no reason to solve for x. It's okay just to solve for the x squared and then substitute for it in the next. I mean, if I solve this for x squared first, here, it'll look like x squared equals y squared plus 9. If I really solve for x, I've got to take the square root of both sides. Now I've got plus or minuses, a lot more complicated. But I honestly don't need the x. I'm plugging into a place that is x squared, and I've got that. So substitute for the x squared without taking square roots. Right? Take this and put it in the place there. Substitute for that variable in the other equation. Y squared plus 9 plus 9y squared equals 169. So we're still following the same steps, just a little different because of the squared. So yeah, remember the steps in substitution are first you solve one of the equations for one of the variables. Then you substitute into the other equation for that variable. Then you have one equation and one variable, so solve for the remaining variable. Now we have to solve for y. So first, what do I need to do to solve for y? Combine like terms on the same side. Y squared plus 9y squared. 10y squared plus 9 equals 169. Then what? Subtract 9. 10y squared equals 160. Then what? Divide by 10. Y squared equals 16. So now we're not done yet. Solve for y. How do I solve for y if y squared is 16? Take the square root. Okay, what's the square root? Plus or minus 4. Remember, when you take the square root, you got to give both the plus and the minus. Okay, that's the one variable. How do I find the other variable? You plug it back in here, but notice that the only place to plug in is y squared. It's not y. So we really can use the y squared equals 16 and plug in to either one. Probably easier to do this one. Right, let's take this one down here. X squared minus 16 equals 9. Solve for x squared. X squared equals 25, which means x equals plus or minus 5. So the points of intersection, we've got two different x values and two different y values. In this case, the answers are going to be 5, 4, 5, negative 4, negative 5, 4, negative 5, negative 4. It's all the possible combinations of these two values and these two values, which means it crosses in 4 places. And you wouldn't know just by looking at this because we didn't do the rest of chapter 10, but that's an ellipse. Oh, sorry, that's a hyperbola and that's an ellipse. It's actually the two shapes that are crossing look like this. Right? It's an ellipse and it's a hyperbola. How many points of intersection are there? 1, 2, 3, 4. And those are them right there. Okay. So try to do this one. I would say you might be better off solving for, one of the y squareds here might make it a little easier. How about this one right here? Start by solving this one for y squared and then putting it into that equation. And if you've solved for y squared, what are you going to do with it? Right, that's the y squared. What do you do with this expression? You put it there. right? You put it in the place of the y squared in the other equation. Right, that's what it would look like. Now you got to solve for the x squared. Anybody get x? Plus or minus 3. And then you put that in up there. That's good. Good job. Now this place right here is where we make a lot of mistakes. Remember, you got to distribute that minus. It's going to flip the sign of both terms before you start adding things side to side. Did anybody get x squared? Did you get it? What'd you say? 3 plus or minus 3. Okay. And x squared is 9. So go up there and put like 9 in the place of x squared. And then solve for that y squared. What does x squared equal? Antoinette? 9, right? If you get this far, right, you combine like terms, you added 25 to both sides, divide by 3, x squared equals 9, which means x equals plus or minus 3. Okay, now how are you going to find the y? Go back up to either one, it doesn't matter which one. Well, actually, we've already, like I said, we have a good place for that. Put it right there. Y squared equals negative 9 plus 25. Y squared equals 16. So what does y equal? Plus or minus 4. So then, you're not done really, because now you still have to label all the points or list all the points, and there's going to be 4 different points. All the combinations of plus and minus 3 and plus and minus 4. 3, 4, 3, negative 4, negative 3, 4, negative 3, negative 4. Let's see. This one is actually a hyperbola and a circle, and obviously crossing in 4 points. Good. So elimination, same steps, same problem. What do we usually do with elimination? We try to get the variables lined up so that they're going to cancel. And they are all lined up. Would they cancel if I added them together as they are? No. But I could either multiply, let's say, the first one by negative 1, or I could just subtract this one minus this one. How about if I multiply this one by negative 1? Right. And what does that give me? Negative 1 times x squared. Negative 1 times negative y squared. Positive y squared. Negative 1 times 9. Negative 9. And then, so now if I look at these here, are they lined up and ready to cancel? Yeah, x squared, negative x squared. If I add them up now, it'll work. So add up the x's, cancel, eliminated. Add up the y's, y squared, 9y squared plus y squared is 10y squared. 169 plus negative 9, 160. Does that look familiar? Yeah, of course. So that's, no reason to go on from there. We know what happens after that. But so you could do, if it's lined up like that and it looks like you can easily cancel a variable, you're probably going to do it that way. You just have to decide which way works better for my problem that's in front of me right here. Well, I mean, we got to the same point that we did on this one. So I'm not going to show the rest because, no, is that the same one? Oh, it was this one here, right? We got to this point right there. So I'm not going to repeat the things we already did. Okay, so try this one. Try to see if you could use elimination. That is the same problem that you had before. See how it is that if you add them together, it eliminates the variable. You got a bunch of stuff for us? All right. Thank you very much. So what is beyond this? So this one is all set up if you add them together, right? You eliminate the y squareds right away. And you end up at a point where we were on the other one. Right? Solve for the x squared, divide by 3, take the square root of both sides. So if you were given the choice, if you were just given that system right there, and you weren't told how to solve it, which way do you think would have been easier? This way or the substitution way? I think this is probably easier because it was already lined up and ready to go. So definitely, if you're given the choice, and let's say on a test you might be, on the SOL you certainly are, then solve it any way you think is easiest. Now, could you solve something like that by graphing? You could. You would have to solve both equations for y, not y squared, for y. And then you would have to, take the square root of both sides. So you'd have a plus and a minus for both. You'd have to use 4 lines in your calculator and then be very clear about which shape you're trying to intersect on the graph. So when you solve nonlinear systems by graphing, the steps are still the same. Solve both equations for y, put them in the calculator on the y equals line, and then do second trace 5, enter, enter, enter. Now you may have to do it more than once because there's more than one intersection point. Okay, so one of them is already solved for y, but I need to solve the first one for y. Right? So this, if I solve this for y, it's going to look like y squared equals negative x squared plus 36. And now I've got to take the square root of both sides. Y equals plus or minus the square root of negative x squared plus 36. Which means you're going to have to use 2 lines to put that in the calculator. You're going to have to put in the plus and the minus. You're going to actually have 3 lines used. Right? This is what it looks like. Right, the first one, I'll put in the x squared plus, or sorry, I'll put in the y equals x minus 2 squared minus 3, enter. Oh, that's wrong. And then I'm going to put in the square root of negative x squared plus 36. All right, get out of that, go down to the next line. And now we're going to put in negative the square root of negative x squared plus 36. Right, that's the plus and the minus part of it. Now, if I look at the graph of that, I'm going to go zoom 6 first. And you can see that this one is a parabola. We should recognize that as a parabola. It's shifted 2 to the right and 3 down. That's this one right here. And the other one must be the other shape, which is a circle. It doesn't quite look like a circle, but you could make it look more like a circle if you did zoom 5. Now, notice that the top half is actually one graph, that's this one, and the bottom half, the minus, is there. Now, how many points of intersection do you see between the circle and the parabola? 1 and 2. So now we've got to go through our steps. Second, trace 5. And it's for the first curve, it's got the parabola. You see it blinking right there. So you say enter. For the second curve, it's blinking on the top half of the circle, which is where we want it. Hit enter. And then we say guess. And it's telling us that intersection point is negative 0.986 for x and 5.9 for y. Now, how am I going to find the other intersection point? Because if I go through the same steps, it's going to always do the same thing. You use the trace and go over towards the one that you're trying to find. It'll go to the closer intersection point. So I move the cursor closer to where it's the second intersection point, the one that I didn't have, and now I just go through the same steps. Second, trace 5. Enter, enter, enter. And now it jumped to that intersection. You know, what if it would have intersected on the bottom half? Then you would have had to, use your arrow keys, make it jump down to the other one. It can be a lot more complicated than that. I wouldn't get too hung up about it, but most of the time it's parabolas and straight lines, and then we don't have so much of an issue. Okay. Right. Try to put those in the calculator. See how many intersection points there are. See if you could find at least one of them. Right, one of them is already solved. The other one isn't. Huh. Ooh, that's interesting. Anybody get an intersection point? There's one. He's got negative 0.37, positive 3.6. Does that look right? So again, if you found that one, use your arrow keys to scroll over or go trace. And now, not second trace, just go trace and arrow over so that it moves closer to the other intersection point. All right. So this one, clear, x plus 4, x plus 4, clear, x squared minus 4x plus 2. See, what does that look like? Zoom 6. Turn it off. Okay. So you see the two solutions? And the first one, whatever it is, second trace 5, enter, enter, enter. There it is. Again, for the second one, somehow or other, you got to get that cursor to move closer to the other point. And I think it might work if you just go second trace 5, and then at that point, move it over. Just move it closer to that other intersection point before you say enter. And now hit enter, and now hit enter. 5.37, 9.4. So I think that when we get on the SOL, I expect there's two systems of equations, nonlinear systems. One of them will probably be a graph like that, where you're just asked to look at the graph and either say how many solutions or what are the solutions, and you estimate by looking at the graph. The other one might be a solve, where you actually have to solve substitution, elimination, graphing, and be a little more exact about it. So that's that. So I'm going to come around and check your U-tries now. You might want to start, there's only 3 problems, right? One for graphing, one for elimination, one for substitution. You might want to do the graphing one now when you got the calculator in your hand.